the core here.
So that I was going through that Kiwi code also. So it is no longer used. Like we are no longer using that. We move to keep one now.
That is correct. Yes. Yeah. Kiwi. We've abandoned. Pardon me. We've abandoned Kiwi because we wanted a task-driven user interface. That is what Glyph requested. So we thought we were going to keep them both alive, but once we started going down the route of the keep, we realized that it was a much better choice long term. So we've just abandoned Kiwi. We should probably take that repo down, I guess. But
okay.
So what we did here was create a private repo in Glyph IT organization inside of GitHub to hold all of the information, all of the artifacts that we use for deploying to Kubernetes. And that's all we've done so far. It is recommended that you deploy to a VM for each of your hosts as opposed to an orchestration tool like Kubernetes for security reasons. But this could certainly get you started. This will get you started getting it to deploy in Kubernetes if you have access to a Kubernetes cluster, learning how it works, and then modifying it to deploy it to hardware or something. So I'm going to go into here because it's easier for me to navigate. So this is IntelliJ open to the VLEI project. The agent itself, no, that's the agent service. So the agent itself has a deployment right here. This is a Helm chart. So if you look at, where are my scripts? If you look at the scripts directory, did I create one for each? Yes. He does. So there is deployment. Well, let me back up. So we deploy the agent using a Helm chart. The Helm chart is located here in agent. It has a config map for loading the configuration information you need to start the agent. It has a deployment, and it has a persistent volume claim, so it can get its own persistent storage, so that we can, if the agent dies and restarts, we have persistent storage for their key stores and their databases. So the deployment for this is found in the deployment.yaml. And again, this is a Helm. I'm not sure if you're familiar with Helm.
Not much. Like
okay, so Helm is a very nice deployment tool for Kubernetes that allows you to templatize your configuration artifacts that you use, the config maps, deployments, pods, services, et cetera, in Kubernetes. And then you can just provide different values when you run Helm to deploy them, and that will substitute the values. And it's a Go substitution syntax for the Go templating language. They then fill in here, so you can. So, for example, we deploy this agent for all of the participants in the pilot program that we ran, and that includes people running as QVIs, people running as legal entities, and people running as the holders of the role credentials. So it's a very powerful tool. If you're going to use Kubernetes for deployment, I highly recommend you.
Yeah, we are planning to use, like, I think you had a call with, you had a chat with Wahid also from Provenant, right? So we are also planning to use Kubernetes for this deployment.
Okay. So the way this works in Kubernetes is you have a specification, and this lists your containers. And this image here is a reference to a Docker file or a Docker container, not file, a Docker container that Kubernetes will pull and resolve it. So in this particular case, you're looking at the values, the image in the repository. So if you look in the values file here, you can see that we're using the Docker container Glyph/agent. That is a container that is built out of this repo. We have a makefile for building this container that packages up KERI in a way that's runnable as an agent, but also includes the keep software built and delivered with the agent, so that the agent is capable of serving up the user interface. So once you're done with this and you deploy it, you can hit the endpoint that you've defined for the particular person, and their agent user interface, the keep user interface, will load and will use the agent as its backend. Okay. So that would be the best place to start, is to, if you look in the make file here, you can see how we build the where is it? Build agent, run agent, build all, build KERI, build agent. Here we go. So this is the one where we build agent. We're using Docker buildx because I am on a Macintosh and I was deploying to Linux machines, and that just makes it easier. You can do it, but you can deploy them, but you get errors or warnings or whatever. So then we use the agent Docker file and we tag it with the latest, and then we push that up to the Glyph organization in Docker Hub. Now you can see that it uses this agent.docker file. So if I open that Docker file, you can see that it's just based on Glyph KERI, which is a push of KERI itself. And then locally, what we do is we build and copy the keep into here for each person that we're going to deploy the agent for. So it's a little cumbersome. Planning on automating this as we go more into production, but for now it works. And then we just copy over the configuration file information for that person, which is located in CF, which is here. So this is the configuration file. I can zoom in on that. This is the configuration file for starting up a person agent. And then also what we did was deploy these with SSL. So we went out and bought a domain name and had to deploy them with a let's encrypt SSL search so that they would serve up so we terminated the SSL in the agent itself. So we didn't create a load balancer over top of this. We just terminated SSL. We tried to, but there were some bugs with it. We couldn't get it to quite work. So the agent itself has a copy of the certificate and serves up on the domain name verifiablelei.org. You of course will use your own, but there's stuff in here to show you how to deploy it with an SSL cert, because you'll want SSL termination at your agent. You could try and set up a router, like an SSL termination router or reverse proxy if you want. We had problems using Nginx doing it, and we were in a time crunch, so we just terminated the SSL at the agent itself. So the one thing of note here is that normally for an agent like this that's going to be exposing an endpoint, you would have the service definition inside of the agent chart. These are Helm calls them charts. Inside of this Helm chart, we deploy them separately because we were trying to move very quickly, and spinning up a service in Kubernetes that has a load balancer takes a very long time, because it has to create, and also, well, it takes a very long time because it has to create an external IP address, reserve an external IP address, create it and connect it to the Kubernetes cluster, and then down into the service. And we were trying to move very quickly. In addition, because we didn't have direct access to the management of the cluster itself, we couldn't reserve IP addresses ahead of time. So this is how we would reserve IP addresses. So we would just deploy the services once, and then we could restart the agents, which with Helm, you just run one command and it tears down and rebuilds the entire chart. So we would rebuild config deployment and the persistent volume claim repeatedly as we were trying to debug this to get it working, but the service stayed itself. So these two are required to get a full service running in the cloud, but I just wanted to explain why they're separated.
Okay.
All
so
right.
Is load balancer working for this?
Yep, this works. If you deploy this, you get a load balancer connected directly to your agent with, I think they're still running somewhere. Let me see if I can. Oops. Yeah, see, I can do. Whoa, what did I just do? Oh, I went to full screen. Interesting. Oh, what did I do with that? Clouds. Yeah, so you can see here we have, this was part of the, can you see that, or do I need to zoom in?
Yeah, I can see
You can
the
see it? Okay.
backup QAR agent.
Yep, so we have the different QAR agents, the lead QARs, we have several person agents, and part of the pilot that we ran was having employees inside of Glyph and a couple of contractors from Ernst & Young receive the LEI role credentials and then use those role credentials to sign the Glyph annual report. That was the whole point of it. So we have agents for each of the persons, which would be similar to ultimately what you guys are going to want to do with custodial agents. And then we had the QAR agents, which were for the Ubi Secure served the role as the QVI. So those are the ones you'd want to deploy, et cetera. So then also, if you look at the services, you can see that for each of one of those, we have a load balancer service with a defined external IP address and all reserving against ports inside of the cluster. So this is all up and running and working. So you could mimic this yourself within, if you use that repo that I gave you access to. And you
So
should
for
probably,
this,
I would recommend you clone or you fork that repo somewhere locally so you can mess around with the configuration yourself. I only gave you read access, so I'm not sure if I'm allowed to give you anything more than that. So anyway, did you have a question?
yeah, one question. So for each of these agents, so we are running like a KERI instance for each of these agents, or
Yes. Yeah. So KERI is behaving like or is acting as a microservice, which is able to respond only to, in the way this is deployed, which is able to respond only for one person who has access to that agent through their passcode.
Okay. And apart from this, like this will automatically pick the latest code from the, I guess, the KERI repo and the keep repo and build it, right? Or sorry, it will use that containers.
Yes.
Image.
It will use the Docker containers that are living in the Glyph Docker Hub repo. They're all public because they had to be together to deploy to Kubernetes. The option for you, if you want to start messing with the code, is to, like I said, fork this repo and then locally change it to point to your own containers and use the code in here to build those containers yourself so that you can start messing around with the code and making changes that you want to make.
Okay.
Is that clear?
And yeah.
Yeah. Okay.
So I have another question regarding the witnesses. So in the demo, like scripts that we have in KERI, we are running 3 witnesses.
Yes.
So for this, how we can start the witnesses?
So witnesses right here, if you look, let me see. I forget what namespace the witnesses are on. I think it's here. Eli, no, that's server pilot. Eli, witness network pilot. So we have several namespaces here because from the this we used for both the beta qualification program as well as the pilot. So
Okay.
Whoops. Oh, that's minus n. And is that right? I don't think that's right. Yeah, that's right. So we have three witnesses running here, and they were also deployed from this. And if you look down here, we have the witnesses chart with his template. So here's his config map and his deployment, and he just runs the KLI witness start command. And I don't think I pointed that out in the other deployment. In the other deployment, he runs KLI agent start. So
Okay.
See the difference there.
And how we are passing to this agent the witnesses, like the URLs?
So that's part of the configuration file. So the URLs here are these are the URLs for the 3 witnesses. So it's the UBIs in the configuration file that's part of the configuration to start up. So that's how he gains access to those.
Okay.
That's the coordination that you need. You need to create your witnesses, get their UBIs, and then pass them to your agents when the agents start up. Now, in the future, where the future version of the keep is going to allow people to configure their own witnesses, and that's the more ideal approach. But for now, this is how we're managing it.
Okay. And in this, under the array of D URLs, I think these are the data UBIs, right? They're pointing to the schemas.
Yep, these are pointing to the schemas. Yeah, and we have a schema server running. I don't know if it was evident here.
I guess you are running the VLEI repo, right?
That is correct. Yeah, right here, VLEI server.
Okay.
Yeah.
So we have like a Helm charts for these also, like the VLEI server.
We do. I don't know if it's probably not in here. Yeah, so the other repo, this one is open source, is this repo here. Containers, yeah, I have a Docker file here for it. And services, this is the services for the VLEI server. So in the what would be the Web of Trust VLEI, it's unfortunate that we named it the same. I understand that. And then where is the schema, or where is the server services?
I think schema are under the samples.
Here it is, VLEI server,
or
VLEI
schema.
server.
Okay.
So this is so these are also Helm charts for deploying the VLEI server. So that's all
Okay.
available there.
Okay.
Yeah, and that's in main. Yep.
Okay. I think, sorry, one more question regarding
Sure.
the LMDB, like the database.
Mhm.
So each KERI will have their own LMDBs, right? Or
Yes.
we can use one LMDB for
No,
all.
each one has their own.
Okay, and they are creating their own database, or
Yep.
like
Yep.
let's say
When
we
you
have
yeah, so when you start it, no, wrong one. So when you start up the agents, we pass in. What do we pass in? Here's where we're passing in all the cert file information, so you can see that at the end for the SSL termination. So, okay, so we don't change it. So when he starts up, he's going to create his database in /var var local, no, sorry, user local var KERI
or yeah.
/ and then whatever name you give him when you create his thing. So what we did was we created the volume. This is the persistent volume claim. We called it data. And then for each agent, we mounted data here onto user local var KERI so that data was external to the running agent and stored persistently in the Kubernetes cluster. So that's how you'd want to manage that. So if you wanted to, and I've had conversations with, I think, Ruth and Chris about this. If you wanted to, if I were looking at building a scalable solution, the agents can be unlocked and locked against any database. And so you would use the same persistent volume across all of your instances and then give them all unique names when they start. And then any agent would be able to unlock itself against any other, as long as no one currently has it locked. Because once you open against an LMDB database, you can't reopen it for writing. So that, like, if you wanted to do a pool of agents, you could do a pool of 20 agents or 100 agents, and then have a layer above that when it receives a request for an agent to do something, it could route you to an available agent, unlock that agent against that data store, and it would be able to use this share that data store across multiple agents. That's just one approach. I've thought a little bit about that.
So I have one question regarding that. So let's say like the data store is logged and some request came to that log database. So will it be able to handle that one?
Yeah, so
Or
in that instance, you'd want to have your routing engine be able to, like, if you had an agent locked against a given data store and you subsequently receive another request for that agent, you would want to route it to the agent that is currently locked to that data store. So in other words, you get a first request, you bring out an available witness and you have him open a data store to use it. And then you leave him open for some period of time, anticipating that the general usage is that you receive multiple requests, and then any subsequent request you get for that agent, you would route to the one that's currently locked against that data store.
okay. So like the witnesses that we are running here in this for deployment, they are running in the like the KERI agents, they are running in the indirect mode or the direct mode?
No, they're running in indirect mode. They're all running in indirect mode, so they're expecting connections via HTTP. I mean, I think the code currently is also listening on TCP. As a matter of fact, I'm pretty sure it is. It is. And so You could connect to them with direct mode, but we're using indirect mode for everything. We're using HTTP.
Okay. And I have I had a issue running on my local system the keep in a unpackaged in a packaged mode. So can you show me how in which order we need to run the commands for that, if possible, for running the keep on my local system?
So building it and then trying to run it.
Yeah.
Yeah. So we're making significant changes to that right now.
Okay.
However, so what I would do, let me just run through. Yeah, I have code checked out right now, but we'll see if I can get it to work. So what I would do in the keep is, here we go. I mean, nope, that's Kipify. So in the keep, I would run package.json, where are we? So I would run one of the package commands. So for example,
Yes.
package root gar. And where did I do this? Because I know I did it here. Okay, I guess I would just do it here. This can work. Yeah, so I would just package it like that.
Okay.
And then give it whatever, 14 seconds to build. Okay, so then its output would be in word build UI, is that right? Actually,
Yeah, build UI. Yes, build dash UI.
so package root gar. Distir word build UI, and then what I would do to make this work is here. Well, this has been a minute since I've done this. Oh yeah, I would just do run. I think it's all encapsulated in run make build person. I'm not sure of that. I thought there was a copy step, but in that VLEI repo in Glyph. Oh yeah, so prepare person. Yeah, so I had shell scripts in here for copying the files into this keep directory, and then as I showed you, the Docker file here expects them to come in here. So
Okay.
that's all I did. If you want to send me the error you're getting, I could maybe help a little more. Again, we're making changes to this, but actually the changes we're making should not affect what you were trying to do, now that I think about that. So yeah, if you could send me that error, I could take a look and see.
Yeah, sure. So that make run command will automatically start the KERI also in the WAD folder.
These makes here.
Like in the keep in the keep project, we have that make files, right? Make commands. Those are mentioned. Yeah.
Interesting. I don't use these. You'd
Okay.
have to talk to Kevin about these.
Actually, I tried these and I was able to build it, but then it was giving error in the
Oh
WAD
yeah,
section.
these are out of date. Yeah, these are way out of date. I'm sorry. I didn't even know these existed because I just use Yarn directly.
Okay.
Yeah, you'd have to talk to Kevin about this. I don't know. Wow, I didn't know there's a lot here.
Yeah. Actually, all the commands that we need are here
Yeah.
defined. Okay. Yeah, sure. I'll talk with.
Yeah, and now, yeah, so these look like they interact with the word stuff, which is what we're moving into a different repo. So it would be important to talk to Kevin to see how that. Yeah, you could reach out to him. He's also on Slack.
Okay. So I have another question not related to the deployment. So let's say you showed in the XPRL demo that we can issue a attestation credential. So how can we verify that credential, or how can we verify signatures it is not tampered with? do we have any APIs or endpoint exposed for that?
So you're talking about doing a credential presentation after it's issued?
Yeah, presentation also, or we want to verify that a credential is a valid one.
So if on the holder side, if you do, for example, if you get a list of your credentials, either through the API or from the KLI VC list command, if it is in your data store, it's a valid credential because the credential won't, from the holder's perspective, so the credential won't be persisted if it's an invalid credential. So
Okay.
if you can list it either via the API or from the KLI list command, it's valid. Now, if you
Okay.
want to present it to a third party, we haven't built that yet. Credential presentation is, we've just finished defining the hidden attributes in AC/DC credentials, which we have to implement. And we've had discussions about the IPEX protocol, which is the protocol for presentation exchange, and we haven't built that yet.
Okay. Okay.
Oh, wow. I scheduled this meeting. The meeting's going to end in 10 minutes. Sorry,
Okay.
if you schedule it, it's a limited number of, it's only 40 minutes, but
no problem. I think you have covered most of the points like related to these. So we wanted to know these Helm charts and how to deploy it. So we'll try at our end. So you are running each of these agents in a separate VM or AWS server, right?
we're running them in a Kubernetes cluster in their own pods. So
Okay.
they're each running in their own VM.
Okay. I think Phil, that's all for now.
Okay, great.
I have the basic understanding, so we'll let you know if we face any error.
Are you still there?
Yeah.
Oh, if you face any problems. Okay, sorry. Didn't hear the end of that. Okay, cool. Just let me know. Again, reach out to me on Slack. That's the easiest way to get me. And we're here to help you guys and anticipate we'll be working closely together. So
Yeah.
just let me know.
Sure. So can you send me this recording that we just did? And
Yes, I will.
okay. So thank you for the information.
Great.
Taking time for.
Absolutely. Thank you. And
Yeah.
enjoy the rest of your day or evening, I guess.
It's night here
Night.
I'm in India. Yeah.
Oh, yeah, it's late night. Okay, cool. Well, enjoy the rest of your night.
Thank you.
Take care.